Hello, everyone, and welcome. I am Maira Duffeck with Oklahoma State University, and I'm here today with Dr. Ashleigh Faris, also from Oklahoma State University, and we're going to provide some updates about corn stunt in the U.S. And so the recent information that we have about these two pathogens in the United States. When you talk about corn stunt, something that you need to keep in mind is diversity of symptoms. So we know that the corn stunt symptoms, they may vary according to the corn hybrid, the time of infection, the environmental conditions, and the pathogens that are associated with this disease complex. So here I brought these two pictures showing the first symptom that I'd like to highlight. That's the reddening of the leaf tips. So as you may see here in these two pictures, we have this reddening of the leaf tips, and this symptom is more concentrated in the upper part of the corn crop. And the reason for that is that the corn stunt pathogens, they translocate into the phloem of the corn plant. So in this way, they tend to accumulate in the young leaves of the corn plant, and that's the reason we're going to start to see symptoms more predominant in the upper leaves, in the upper part of the canopy. Another symptom that we also observed in cornfields is the yellowing of the leaves. So what we have been seeing is that the difference regarding hybrids. So in some hybrids, we're going to see more predominant the presence of the reddening of the leaves. And then in some corn hybrids, we're going to see the presence of this yellow color more predominant here, as you may see in these two pictures. And this is very visible when you look at the border of the field. We start to see these plants that are showing symptoms of corn stunt compared with ones that are still green and not showing symptoms yet. Another symptom that's common observed in corn fields affected with this disease is the chlorose streaks. As you may see here, we start to see these chlorose streaks with different patterns, as you may see here in these three pictures. And in the same way, we're going to start to see the accumulation and the predominance of those symptoms in the upper part of the canopy. We also see this symptom more predominant in the border of the field, in the plants that are more severely infected with corn stunt. Shortening of the internodes is another symptom that we commonly observed in the borders of the field, in the plants that got infected early on in the season, and they are heavily affected by this disease. So as you may see here, we have the shortening of the internodes, and this symptom is going to cause the stunt of the corn plant. That's actually the symptom that gave the name of this disease, corn stunt. And as you may see here, we're going to start to see these symptoms in the borders of the field with stunted plants. Overproduction of ears is another common symptom that we observed in plants that got infected early on in the season. So in this case, these plants got infected when they are still in the vegetative stage, and then when they reach the reproductive stage, they start to develop multiple ears in one single plant, as you may see here in these three pictures. So we have here the presence of 4, 6, 3 ears in the same plant. And the problem with that is that none of these ears, they're going to fill up grains. So they're not contributing to the corn yield. And another symptom that we are observing now in the cornfields affected with corn stunt is the adventitious roots on the brace roots. So as you may see here in this picture, when you look at the plant, in the upper part of the plant, we start to see the normal symptoms of corn stunt, such as the reddening, the chlorose streaks. But when you look at towards the root system, we start to see the production of these adventitious roots. And most of the time, when you test these plants for corn stunt pathogens, they came up positive for those pathogens, at least for one of those pathogens. When I talk about corn stunt, we need to keep in mind that there are several challenges regarding the diagnosis of this disease based on the symptomology. And the reason for that is that corn stunt doesn't have specific symptoms as other diseases that we usually work with. So for example, the leaf reddening, the chlorose, and the stunt of the plants, they can also be caused by other factors in the field, such as nutrient deficiency, drought stress, herbicide injury, and other corn diseases. So I brought here the example of phosphorus deficiency. So in this case, phosphorus deficiency also caused the reddening of the leaf of the plants. And this symptom can also be confused and mistaken by corn stunt. Another example that I brought here is the maize dwarf mosaic of corn, that is also a disease that affects corn and causes the chlorosis streaks of the corn leaves. So as we see here in these three pictures, we have the chlorosis streaks on the showing different patterns in these corn leaves, and also the stunt of the plants. So this is symptoms that are not just characteristics of corn stunt, but also may be associated with other corn diseases, such as maize dwarf mosaic of corn. So the question that I have is, how do we diagnose corn stunt based on the symptoms alone? And the short answer for this question is that we can't. When we see the symptoms of corn stunt in the field, we need to pick up samples and send them to a laboratory where they're going to run some molecular tests, such as PCR, and they're going to be able to identify if the symptoms that we are seeing in the field are associated with the corn stunt pathogens. So in this way, we can provide an accurate identification of those pathogens cause the disease and provide a reliable diagnosis for the growers. And this is a problem because this ended up increasing the cost for diagnose the problem that you are seeing in the field, such as the corn stunt disease, and also the turnaround time for receiving the results back from the lab. So we're going to have this delay in the diagnosis, because we're going to need to collect samples, send to the lab, and wait for the results. And this can take from 1 to 2 weeks until we have the results back. So this is something that you need to keep in mind when you think about diagnose corn stunt. So we talk about this disease, but what causes corn stunt, right? So we know based on the literature from other countries in South America and in the Central America that have been dealing with this problem for a long time, that corn stunt can be caused by 2 bacteria and 2 viruses. So the bacteria that cause this disease, the predominant one is the corn stunt spiroplasma. And we also have the presence of the maize bush stunt phytoplasma. So we have 1 spiroplasma and 1 phytoplasma associated with this disease. And the 2 viruses, we have the maize raiado fino virus and the maize estrate mosaic virus. And we know that these are the common viruses that we see associated also with corn stunt. However, in the United States, these 3 pathogens have been associated with corn stunt symptoms. That is the spiroplasma, the phytoplasma, and the maize raiado fino virus. The estrate mosaic virus was not detected yet, causing corn stunt in the US. So when we first detected the symptoms of corn stunt in Oklahoma in 2024, the question that we also tried to answer was, what is the distribution of corn stunt in the United States? So we would like to have the map the distribution of corn stunt, not just in Oklahoma, but in other states as well. So to answer that question, we conducted a survey in several states across the United States, where we received corn leaf samples from those states, and we test them at Oklahoma State University for the presence of the main pathogen associated with corn stunt, that is the corn stunt spiroplasma. So with that sample, we test a total of 133 corn leaf samples that were collected from 11 states. And the results from that survey is that 79 samples test positive for corn stunt spiroplasma, and 54 samples test negative for corn stunt spiroplasma. So you may see here that we have a little bit more of 50% of the samples that we received from 2024 that test positive for this corn stunt pathogen, the CSS. And the challenge that we observed with the survey is that not all the samples that were showing symptoms of corn stunt, they test positive for the corn stunt spiroplasma. And this information brought us to our next research question that we try to answer. So it is corn stunt spiroplasma the primary agent behind corn stunt in Oklahoma? So what we try to investigate here is that if you have just corn stunt spiroplasma associated with those corn stunt symptoms in 2024, or if you also have other pathogens. So to try to answer this question, we collect corn leaf samples from several counties across Oklahoma from August to November 2024. And we test them again for the corn stunt spiroplasma, but in this time, we also test them for the maize bush stunt phytoplasma. We wanted to see if this other bacteria was also playing a role in the development of the disease in this state. And the results that we got from that survey is that we tested a total of 16 samples. And from that samples, we have the result that 8 of them test positive for corn stunt spiroplasma, 5 of them test positive for the phytoplasma, and then we also investigate which samples test positive for both of those pathogens. And we have here that 5 samples test positive for both the spiroplasma and the phytoplasma. In this way, we're kind of showing a co-occurrence of these 2 pathogens that cause corn stunt in the fields. So we know that in the same way here, we have a percentage of 50% of the samples that test positive for the spiroplasma, a little bit lower percentage for the phytoplasma, but then the same percentage, 31%, test positive for both pathogens. So in this case, we still don't know if these 2 pathogens have a synergy between them or how they are interacting the corn plant. But we noticed that when the samples collect for the corn field test positive for the spiroplasma, they tend to test positive for the phytoplasma as well. And to try to answer the same question, we also use the same approach, but in this time testing a different sample. So we test the sample of corn leafhoppers that were collected in several counties across Oklahoma, because the corn leafhopper is the insect vector that transmits the corn stunt pathogens to the corn plant. So in this case, we use samples that were collected also from August to November 2024, and we test them for the same pathogens, for the spiroplasma and the phytoplasma. And the results that we got from the analysis of the corn leafhopper is that from the 40 samples that we tested, 20 samples test positive for the corn stunt spiroplasma, 42% test positive for the phytoplasma, and 32% test positive for both of those pathogens. So in the same way here, we are seeing again this 50% of the samples testing positive for corn stunt spiroplasma, but not all of them, right? And in the same way, we think that we're showing this co-occurrence of those 2 pathogens together in the same corn leafhopper sample. And as I mentioned, we still need to investigate more to see what is the relationship or how these pathogens are interacting inside the corn leafhopper and also inside of the corn plant, and what's the reason that we are testing positive for the phytoplasma in the same samples that test already positive for the spiroplasma. So how about 2025, right? So in 2025, we established this working group for monitoring both the corn leafhopper and the corn stunt symptoms across the United States. So this working group counts with the participation of researchers from several universities in the main corn production regions in the US. And also, it was just possible the establishment of this working group because we got funding from the Southern IPM Center. How about the distribution of the corn stunt pathogens in 2025, right? So with the data collected from researchers that are part of this working group, we're able to have this updated map for the corn stunt pathogens. And as you may see here in this map, we have some states that have the presence of the corn stunt pathogens in the corn plants during the 2025 growing season. And we have 2 colors here. So in yellow, we have the counties where corn plants test positive for the corn stunt spiroplasma. And in orange, we have fields from our collect samples that test positive for both pathogens, for the corn stunt spiroplasma and also for the phytoplasma. So as you may see here, we have less states that test positive for corn stunt disease during the 2025 growing season compared with the 2024. And we have here a county in Oklahoma and in New Mexico that test positive for both pathogens. So we're seeing that in this case, we have still the higher predominance of the corn stunt spiroplasma for the 2025 growing season in the same way that you had for 2024. And then a lower percentage of the fields that test positive for corns for the phytoplasma as well. So the phytoplasma was present in 2025, but not having the huge impact that had in 2024. And here you can see that interesting that New York State tests positive for corn stunt diseases, but the disease was not reported in other states in the northeast part of the United States. And another question that we have is how do we manage this disease, right? So we already covered the symptoms, the distribution of the pathogens that cause the disease, and you're probably wondering how do we manage corn stunt? So the short answer for this question is that we don't, at least not directly. So once we start to see the symptoms of corn stunt in the field, there's no product that we can apply in the field that's going to slow down the development of the symptoms or is going to stop the reproduction of those pathogens inside of the corn plant. So the management of this disease relies on the management of the insect vector, the corn leafhopper. That is a topic that's going to be covered now by Dr. Ashleigh Faris.
All right, thanks, Maira. So my name is Ashleigh Faris. I'm the Cropping Systems Extension Entomologist and statewide IPM coordinator for Oklahoma State. And I'm going to briefly talk about some reminders of Dalbulus maidis, its characteristics of its life cycle, before we dive into what we saw in 2025. So just a reminder, this insect is only going to reproduce in corn. Females are typically going to lay their eggs into the leaf tissue along the midrib of our leaves of our corn plants. And so the eggs are so small, and since they're in that tissue, they're not going to be visible to the naked eye. Depending on temperature, eggs can take anywhere between 8 to 11 days to actually go ahead and hatch and move into nymphs. Our females can be quite prolific in the number of eggs that they can produce in their lifetime, laying several batches that can lead anywhere to between 130 to over 600. For the nymphs, they progress through 5 nymphal stages, and those can take anywhere between 13 to 17 days to progress. These are typically going to be found deep within the whorls of our vegetative corn, but on our reproductive corn, we're often going to see them move out of that protected vegetative region to the undersides of leaves. A lot of times on those lower leaves is where we're starting to see them up all the way to eye level, sometimes even up along the leaves that are wrapped around the tassel as that tassel is forming, basically looking for a productive place or a protected place rather to be kept. And so when we think about the adults, they're going to be our winged insects. So those nymphs are wingless. Our adults are winged. They're very, very mobile. They're going to be darting around very quickly, and they're relatively small insects. Things that might help clue us into seeing them in the field are going to be their exuviae, so those cast-off skins as they're molting through those instars and into adulthood, as well as some of that honeydew, which can turn into black sooty mold. So this is basically them secreting that extra liquid that they're feeding on out of the plant, and then it is a very sugar-rich substance that once exposed to the elements can turn into that black sooty mold. So we know that based on literature and past studies related to corn leafhopper, that when the females are infected with the corn stunt spiroplasma, their survivorship actually increases. So this pathosystem is very closely related and has evolved together over time to where that insect and the pathogen know that it's a benefit for them to go ahead and progress through development together. We also know that for cold tolerance corn leafhoppers, they can survive cold temperatures up to about 23 degrees Fahrenheit for 8 hours. But after 8 hours or anything below 23 degrees Fahrenheit, that's where we really start to see some susceptibility to those colder temperatures. We can have anywhere between 2 to 12 generations per year. This is going to be, of course, temperature specific and also population specific, but we have seen in literature up to 12 generations being documented in a population, 14 documented in a population in Arizona. And we know that they can live for a long time as long as they have some sort of a water resource. So they can survive up to around 9 weeks off of corn as long as there's some sort of a resource that they can get water access from. So some things that we've learned and how we talk about identification of this insect, because it seems like for most people, we didn't realize just how many leafhoppers were in corn until we actually started to pay attention to leafhoppers in corn, specifically looking for the corn leafhopper. So just a reminder, this insect is overall going to be yellow to tan in color. There are light morphs, there are dark morphs. Like with a lot of insects, we also see that as the insect ages, that cuticle can darken. Usually the size of this leafhopper, I would say, is about a good middle size leafhopper in terms of comparing to others. So it's going to be about the size of a grain of wild rice when it is an adult. What we notice is that it has two dark spots in between their eyes, which you can see in the picture on this slide. But there's also this light coloration, kind of like halos surrounding it. I want to be very clear that these two marks alone, just like with a lot of insect characteristics, a diagnostic character is not going to only be specific to one. It's going to be a combination of characters that are going to help us to identify it. So this is not the only leafhopper that has two dark spots between the eyes, but in terms of leafhoppers that are in the US and in areas where we have found the corn leafhopper, it's usually going to be one that also has a clean face to it as well. So look at the face of the insect, make sure there's no additional markings on there, and also look for those two dots. And in combination, that should give you a pretty good idea of it actually being Dalbulus maidis versus not Dalbulus maidis. So be sure you really inspect that insect head on and then also from the top as well. Now, the other thing I want to note is we have noticed again a lot of different leafhoppers, and this is just a sampling of ones that I've had submitted to me by colleagues in Texas, as well as here in Oklahoma and also in Kansas, that we see commonly confused for the corn leafhopper. Now, these are not ones that cause problems for us in corn. I will say the greatest offender for us in Oklahoma we saw was the aster leafhopper or the six-spotted leafhopper. I know that in talking to colleagues out of Texas, the black-faced leafhopper is one that is very commonly misidentified. So you can see that some of these have different kinds of dots between their eyes. So again, you're looking for two dots between the eyes plus that clean face in order to indicate that it's a corn leafhopper. So let's look at what actually happened in 2025. Think about lessons learned that we have from then, as also what we learned from 2024, and putting this information together for integrated pest management guidance moving forward. So in 2025, we did not have documented corn leafhoppers in Oklahoma. The last time that we saw them in the state was going to be the end of 2024. It seems like temperature was really the limiting factor for us. We got some nice, long, extended freezes that helped to knock back those populations. That also seems to be holding true for Texas as well. They didn't notice any in the upper part of South Texas or in Central Texas. What they did find, though, was that they had a population in the lower Rio Grande Valley, which is that red highlighted region on the map here, where they found that there were some corn leafhoppers that were on volunteer corn in that area. So if you're familiar with that part of true South Texas, as I like to call it, you know that sometimes they have fairly mild winters. They don't always get a good freeze. They might have kind of a frost event, but nothing for extended periods of time on different years. So that's what we saw last year. In 2025, South Texas also saw unprecedented levels of rain at specific locations. And so it wasn't all across South Texas, but it was in localized events. Some places had up to 11 inches. We were hoping that maybe that was going to knock out the cornleaf hopper, but unfortunately, it didn't really impact populations, it seems like. Eventually, they did start to move northward. So for us in Oklahoma, we had our first report received through some industry partnerships on June 23rd in Choctaw County is where we first saw them, and that's where that yellow icon is on the map there. This is really following a similar timeline to when they were located in Texas. So they were moved further north. We saw them basically in the end of July, beginning of August, further north into Oklahoma. But what we know in talking now to different scouts, consultants, and also industry partners is that around this June timeline, this late June timeline is similar to what we saw in 2024 as well. So we know that we had some of our double crop corn that was delayed in planting and also wheat being harvested in Oklahoma too. So our planting timeline for our later planted corn was pushed a little bit further back this year. And we did receive that we had some reports this year in 2025 of yield losses in double crop corn. But the really important thing for us moving forward and really for all states to be sure that we can tie these losses to corn stunt is actually testing of that leaf tissue. And I'm going to explain why here in a moment, that's so important for us because we have years that are basically boom or bust when it comes to the pathogen prevalence versus also the population or abundance of leafhoppers that we have in a system. So it seems like in 2025, compared to 2024, we had lower corn leafhopper populations, and we also seem to have lower pathogen incidence. In talking to different neighboring states and their pathologists and and our industry partners, and what they were able to detect and determine. Ultimately, what this means is we have a reduced disease risk. So in 2025, that working group that Maira introduced earlier, which she is our fearless leader for, we also had states that were documenting where the corn leafhoppers were being detected. And so we had some states that had some pretty significant activity. So Texas, Oklahoma, we had some as well that was documented, as well as into Kansas and then even into Nebraska. You start to see that in some states like Louisiana and New Mexico, over into Alabama, and then also into Georgia, that there's some fewer incidences that were reported or noted. But you also see that we had a nice projection northward up into, Iowa and states beyond as well. And so, really, when we think about the timing of our corn leafhopper arrival, we need to also be considering the timing of our growth stage at which our corn is at whenever those corn leaf hoppers arrive, because we know, as Maira was mentioning, that if infection happens earlier in the growth stage of the plants, then most likely symptomology and also yield limiting factors are going to be more impactful. Whereas if you have an infection at a later stage, a reproductive stage perhaps even, then you're probably going to be having a lesser of an impact on that yield. So being aware of what those typical dates are, your growth stage is really going to be useful for you moving forward with your integrated pest management plan. So, based on some trial and error and in talking to groups of different entomologists, we have seen that there's different methods of which we can scout and monitor our insects. And one that we're really big advocates for has lately been the vacuuming. And so there's two different methods you can do this. You can purchase a leaf vacuum. So this is not a leaf blower. It is truly a leaf vacuum. You can get these at places like big box stores as well as also online. And what you'll do is you'll basically take some pantyhose or thigh highs because they have the nice tight band around them. You place them inside of the tube of the leaf vacuum, and then you make sure that that stocking goes into the tube as well. And then you go around and you suction multiple plants in a field at multiple locations. And it only takes you to go ahead and sample for about 2 to 3 sections on each plant. This is really useful when your corn is at that early development stages of whorls. What I will say in double cropping systems or in areas where we had a lot of refuse, there were reports where these were a little bit more tricky to use. That's where having kind of this handheld car vacuum was really nice, not as powerful, but still effective at being able to sample from the whorls, see if you have any corn leaf hoppers in there. The reason for the thigh highs also is then you can take that thigh high out, you can tie it off in a knot, place it in a plastic bag, put it into a freezer, and then you can go through those samples and look and see if you collected any corn leaf hoppers. The car vacuums, you can also see that you've got a clear canister. You can usually detach those canisters and then place them into a freezer so you can sort through samples as well then. Another really great tool that in talking to consultants from across different states is that we're seeing they're preferring even visual inspection if they have the time and ability to do this. So again, inspect those whorls at those vegetative stages, at reproductive stages. When you're talking about the corn getting to be much larger, you need to be careful where you need to be taking your time. So walking into the field, usually starting at those edges and also suggesting that you're starting in the morning. Usually the corn leaf hoppers aren't going to be moving around as much, but they are going to be on the outer parts of that plant, on the underside too, because the temperatures are cooler as well. But walk into that field a few steps, stop, take a moment to kind of just be still, look around at eye level, and start to notice if anything is moving. Really, once you're able to train your eye, it's not so hard to try and figure out that what you're looking at is possibly a leafhopper, and then hopefully you can collect some samples to be able to confirm that they're actually corn leafhoppers. Another standby method is, of course, the sweep net. And so you can do this anywhere between those vegetative stages where you can just then tap the top of the plants as you're going over them. And you can do kind of a figure-8 motion in front of you or just as you're going down the row. If you move into reproductive stages, then you can also sweep net up and down, depending on how tight your row spacing is, it may not be as feasible, but this is another solid method for being able to sample what's in your field. And another one that was used by our working group is the yellow sticky traps. And so this one is also one that is kind of debatable how you want to manage it. I will say this is really useful for if you want to have a sample that you actually want to test to determine are the corn leafhoppers that you have in your field infective. The other thing that I want you to think about is what is a method that you're actually going to do. So for the sticky traps, I know that it's a little limited because you're asking for a very small insect to land on a smaller object in a field that is very, very large. But depending on how intensive you need to be in terms of your management practices, this might be a very easy way for you to go ahead and monitor and see is that corn leafhopper there. You can place it on a fence. You can come by and check it weekly as you kind of get more regular reports. Then go ahead of what's coming maybe from the south. And if you have concerns for the corn leafhopper, increasing the frequency at which you're checking and replacing these sticky cards is really important. These are also easy for you to hand over to your extension specialist so that they can actually check and determine if it's a corn leafhopper and if they're infective as well. You want to adjust to the height of the canopy of your corn. We find that usually correlates to where that activity of the corn leafhoppers are going to be flying around too. So ultimately, some people said that carrying around that big leaf blower vacuum, not exactly feasible for them. So that might be a limitation because the battery and also the weight of the machine is heavy itself. You do have to have battery power visually inspecting. Some of us are better at spotting differences than others too. They can move around pretty quickly, so maybe that's also not something that's your forte, but you have lots of different options that you can choose from in order to help you with identifying this pest. Now, things that we need to think about moving forward are going to be some integrated pest management guidance. And so what I'm going to share with you here comes out of a meeting that Dr. David Kearns with Texas A&M University held, where he brought together industry partners, researchers, as well as consultants. And we sat in a room and we talked about what exactly have we seen over these last 2 years and what is some guidance we can give moving forward. The first one is plant early. Now, again, this is really important if you're in an area where you might have a readily available corn leafhopper population so that you can go ahead and be sure to get it in the ground and get it going before those populations really build. Now, there's going to be some circumstances this isn't possible. If you're planting double crop, you can't exactly plant any earlier than when you get your wheat out of the ground. So imagine that not all of these are going to be a one size fits all, but try to pick a group of different kinds of tactics that you can use. We also want to think about managing your volunteer corn whenever your season ends. This is especially true for our southern states, anywhere that really has a mild winter. For us in Oklahoma and beyond, typically Mother Nature is going to take care of that volunteer corn for us because of freezes, or it's going to also be taken care of by maybe a tilling practice if that's something that you do on your operation, or even grazing is a way to manage this corn as well. The reason we want to do this is because we're removing that reproductive host. Remember, corn leafhoppers only reproduce in corn. And we're also removing that pathogen reservoir, okay? So by doing that, it's helping each other out. This is really important for places like South Texas. Now, when we think about how we're going to be managing our second crops, we want to be considering how we're going to break that green bridge. And so by that, we mean have a delay of maturity for your first crop and that planting of that second crop in order to allow for the corn leafhoppers to hopefully disperse to another area away from where you're planting and then allow you to be able to go ahead and plant in your second crop. And so this is a common practice that would be found in areas where you can kind of have continuous corn crops. Thinking about also, maybe management of nearby fields too, of corn is also going to be very, very important, and seeing what's going on there before you start to plant maybe some double crop corn following your wheat if you're in that kind of a system. So we're recommending anywhere between 3 to 4 weeks for grain crops and then anywhere between 2 to 4 weeks for your silage corn crops. Now, in terms of seed treatments, this is really critical depending on where what you're planting, when you're planting, and when the arrival of the corn leafhoppers is there. So for those southern areas where corn leafhopper populations might be ready just to jump into where you're planting, you should probably look at investing into a higher rate insecticide seed treatment. This is also true when we're talking about areas where you're doing that second crop, where there's already a corn and corn leafhopper population that has been around, and you're either going to plant a second crop of corn or do double crop, you should probably invest in that higher insecticide seed treatment rate. So based off of studies out of David Kern's group, he has seen that Poncho or Cruiser at the 500 level is really useful, for giving you some sort of management to get through those early vegetative stages up to about V3. And then for the Poncho or Cruiser 1250, it has pretty nice efficacy to also get you through the V3 stage whenever you have an increased population of those corn leafhoppers, giving some protection. And just an observation that he's made is that Poncho seems to perform slightly better than Cruiser. And so more studies looking into this and also how these seed treatments are affecting the corn leafhoppers are something that entomologists need to look forward into doing in the future. Now, when we were previously talking about when we should apply foliar insecticides and for how long we should be protecting our crops from the corn leafhopper, specifically, corn, protecting it from the corn leafhopper, we were recommending at first up through V8. But what we've noticed is that for our hybrids, like what Maira was showing earlier, is that really hybrid susceptibility for what we have available on our US market is very different from the hybrids that are available in these other areas and other countries where this disease and the insect has been endemic. And what we're finding is that we need to be protecting our hybrids that we have in the US probably through the R1 stage. And so that's a little bit longer, but that guarantees that by the time there is an infection, then the growth of that corn should outrun the amount of time it takes for that pathogen to actually cause any kind of yield limiting symptomology. And right now, there's not an economic threshold. That doesn't necessarily mean that we need to spray on site. Instead, we need to be considering what's going on in this pathosystem. We need to be thinking about the pathogen prevalence, and we need to also be thinking about the corn leafhopper population that we're having available to us in order to help inform our decisions moving forward. So the way that we're kind of framing this is thinking about, again, that corn leafhopper population and that pathogen prevalence, and that's going to inform our action threshold. And so at some point, we know some of us are more risk tolerant and others are more risk averse, is what we would say. But a low risk situation in this action threshold area would be a low amount of pathogen and a low amount also of that vector, the corn leafhopper in this case. So this is kind of a low risk situation. We've got our moderate risk situation where we're going to have a low amount of that pathogen, but we're going to have an increased corn leafhopper population. This is where we might have a moderate risk, where we have a number of vectors around that may have had a lower chance of interacting or being able to pick up and then become infective and transmit that pathogen. And then we could also have a moderate to high risk scenario. So we've got a high level of pathogen, and then we've got, though, a low level of our corn leafhoppers. And so likely the low population of corn leafhoppers are probably going to be infective. However, they're not going to be as numerous as they would be necessarily in a high risk situation where we've got a lot of pathogen and we've got a lot of the vector, the corn leafhopper, flying around, at which corn stunt is probably going to be inevitable for some of us in trying to manage our fields. So paying attention to what's going on south of us, even outside of the US, I think is going to be very important for us moving forward, where we can kind of get a warning of what's happening in some other areas in terms of leafhopper populations and also in our pathogen prevalence. So this past summer, I worked with some colleagues and also Dr. Duffeck's crew, and where we were able to conduct some insecticide trials. And so we planted double crop corn, and we planted it after we were sure that we had corn leafhopper populations present here in Oklahoma so that we could have nice populations of the vector around for us to be able to do some efficacy trials on. We did in-furrow applications, which I'm not showing here. And the reason for that is when we did an in-furrow application of Savanto Prime, what we found is regardless of the rate, there was no impact in terms of how it was able to reduce the number of nymphs found inside of our trials. And so moving forward, since that's also not a product that is labeled for in-furrow for corn or corn leafhopper, it's not something that we're looking as promoting as a management guidance. Those results were very similar to what were also found and documented in other states as well. However, for our foliar applications, we were able to see that we did find mean percent nymph reduction at 3, 7, and 14 days after treatment. And the results that I'm showing here for these different products at these different rates are kind of broken down into that dark green of what we would call better efficacy, where we have also that light green, which is mid-range efficacy, if we want to think of it that way, and then little to no efficacy is highlighted there in the yellow. And you'll notice that a lot of our pyrethroids are grouped down in that yellow. So pyrethroids overall, not very effective. What we can say is that based on observations, not only here in Oklahoma, but also in other places like Texas and Missouri, we find that our most effective products are going to only have efficacy for about 14 days. And so that does mean there may need to be repeated sprays applied depending upon that growth stage and where you're at in the season for your populations. I do want to note the reason we looked at percent nymph reduction here in Oklahoma is because we were able to look and see, instead of thinking about migration of that insect flying in and out of the plots, we're able to instead have an idea of what those insects are that are not as mobile, see if that reproduction was increasing, decreasing, or slowing down. So that's why we chose to look at the nymph population. So overall, best performers were Indigo at 4.5 fluid ounces per acre, Steward 8 fluid ounces per acre, and 10 fluid ounces per acre, and then also Savanto at 7 fluid ounces per acre. Overall, what we found to be most consistent in terms of the trials across our 3 locations and ones that we are suggesting that our growers use moving forward is Savanto at 7 fluid ounces per acre and Steward at 10 fluid ounces per acre. So I do want to share some chemical control considerations for moving forward. We want to be sure that we are reducing risk. So we need to notice that we're not talking about control of our insect. We're talking about suppressing that population. Again, like I said, we have insects that are flying in and out of the system. These corn leafhopper adults are highly mobile, so we're not going to knock them out completely. We're going to suppress them. And again, we might require multiple sprays just depending upon where you're at in that growing season. One really important thing to note, Dr. Duffeck mentioned that there's symptomology that can be confused for corn stunt. That's not exactly corn stunt, but some other kind of environmental or nutritional factor. The same thing when we talk about what we're spraying on our corn at the time that we're also spraying it. So there's evidence that spraying non-ionic surfactants will actually cause arrested ear development. And that can ultimately also look like corn stunt symptoms, so poor filling of the grain. So if you're spraying this at pre-tassel, that's something for you to be aware of that actually can be a problem and be confused for corn stunt. Be sure that you're not just going for the most inexpensive option. We know pyrethroids in some environments can actually flare spider mites. We also know they were not effective insecticides for us in our trials. We also want to be sure that we're conserving that natural control, so don't go with a broad spectrum insecticide. We have been observing parasitoids as well as various different kinds of predators like lady beetle larvae, syrphid larvae, and also spiders that are preying on these corn leafhoppers in the field. And when we think about our history of this system and how it's moved from the past to the present, we really need to be considering, again, that arrival time of Dalbulus maidis and also those corn growth stages at which they arrive and when those corn growth stages are susceptible becoming to and being infective. And there's really a lot for us to learn, especially again with the hybrids that we have here available in the US. And I know that's something that our industry partners are working on as well as other researchers too. In 2024, we had a lot of information and concern that was being expressed and coming out of areas like Argentina, Brazil, and Mexico, where we saw that corn markets were being severely impacted by corn stunt disease. We didn't really have these alarming stories in 2025. And if we think about this, it's probably because, again, that pathogen and vector population was very different between the 2 years. So, again, paying attention to what's coming out south of us might be a good predictor of what we maybe need to brace ourselves for or prepare ourselves for that coming year. We know historically, every 7 to 10 years, we can get a cycle of corn leafhopper outbreaks. Historically, these have been in places like Texas, California, Florida, other Gulf Coast states. However, when we have the corn leafhopper outbreaks, we don't always have corn stunt disease. And so again, think about, we may have years where we have high numbers of insects. However, it may not be worth the investment to spray if we're having a low pathogen prevalence at that time. And again, remember the importance of testing to confirm so that you know for sure symptoms you're seeing in your field actually are representative of corn stunt itself. And really, we're just looking to see what are we going to see in 2026. We don't know yet, but we're hoping that if we have it or we don't, we at least now have tools for moving forward that we can implement in order to make this, I think, a little less scary and a little less threatening of a pest. So for the future, I can't stress enough to pay attention to what's happening south of you. And then also, if you're in the south, think about managing that volunteer corn. Again, that's very location dependent. If you're in those warmer climates and areas where you have the leaf hopper and also the ability to grow volunteer corn, you're removing the reservoir for the pathogen as well as also for reproduction for the host. You want to consider seed treatments if that's something that is useful for you based on your planting location and also your practices and your timing of your planting. Also, be sure that you're actively scouting for the corn leaf hoppers. We gave you examples of different tools you can use for that. Understand that the corn leaf hopper populations and those corn stunt disease pathogens are going to be fluctuating. It's going to vary year to year. So not every year is going to be the same as the previous year. So just again, be paying attention to what's happening to the south of you. And be sure you have insecticide on hand. We know, based on trials in multiple states and multiple locations in those states, that Savanto Prime and Steward EC have shown the best efficacy against these leaf hoppers. So being able to reduce the risk of corn stunt is going to be something really important for you moving forward. And when you're applying those, be sure to, use best practices that way to ensure that you're not wasting your time, your money, and also that resource. So with that, our evidence our practices moving forward of what we're going to do for integrated pest management, they're going to be evolving the more that we learn, the more we're able to do research, and the more we observe this in the field. So just stay tuned, but I think you have a good handle on what you can expect for the future. So with that, like to close us out, if you have any questions for Dr. Duffeck or for myself, feel free to reach out to us through our emails that I have listed here. And then also, you can follow us always on Instagram too. Thanks.